Welcome. Today, we are looking at forces. This is topic 4 in your SS1 physics series. This topic is common in both essay and objective questions in your examinations. Pay close attention. Let us begin. First, let me explain what a force is. A force is a push or pull on an object. It is an interaction that can change the motion of an object. Force is a vector quantity. It has both magnitude and direction. The SI unit of force is the Newton. 1 Newton is the force required to accelerate a mass of 1 kilogram at 1 meter per second squared. Forces are everywhere in nature. They are responsible for motion, stability, and deformation. Understanding forces is essential for understanding mechanics. It is essential for understanding how objects interact. Without forces, there would be no motion. There would be no life. Forces are fundamental to physics. Now let me explain the types of forces. There are several types of forces. The first type is contact forces. Contact forces occur when objects touch each other. Examples include friction, tension, normal reaction, and applied force. The second type is non-contact forces. Non-contact forces occur without physical contact. Examples include gravitational force, electrostatic force, and magnetic force. The third type is internal forces. Internal forces act within an object. The fourth type is external forces. External forces act on an object from outside. Understanding the types of forces is essential for analyzing physical situations. Now, let me explain gravitational force. Gravitational force is the force of attraction between two objects. It depends on the masses of the objects. It depends on the distance between them. The formula for gravitational force is F equals G times m1 times m2 over r squared. G is the gravitational constant. m1 and m2 are the masses. R is the distance between them. Gravitational force is a non-contact force. It is the force that keeps planets in orbit. It is the force that causes objects to fall. Gravitational force is one of the fundamental forces of nature. It is essential for understanding the universe. Now let me explain weight. Weight is the force of gravity on an object. It is the product of mass and gravitational acceleration. The formula for weight is W equals mg. W is weight. M is mass. G is the acceleration due to gravity. On Earth, G is approximately 9.8 meters per second squared. Weight is a force. It is measured in newtons. Mass is the amount of matter in an object. It is measured in kilograms. Weight depends on location. Mass does not. For example, an object weighs less on the moon. The moon has less gravity. Understanding the difference between mass and weight is essential in physics. Now let me explain friction. Friction is a contact force. It opposes motion between two surfaces. It acts parallel to the surfaces. Friction is caused by the roughness of surfaces. It is also caused by adhesion between surfaces. There are two types of friction: static friction and kinetic friction. Static friction acts when objects are not moving. It must be overcome to start motion. Kinetic friction acts when objects are moving. It opposes motion. Static friction is usually greater than kinetic friction. The formula for friction is F equals mu times N. F is friction. Mu is the coefficient of friction. N is the normal reaction. Friction is essential for many everyday activities. Without friction, we could not walk. We could not drive. We could not hold objects. Now let me explain the advantages and disadvantages of friction. Friction has both advantages and disadvantages. Advantages of friction include walking, gripping, and braking. Friction allows us to walk without slipping. Friction allows us to hold objects. Friction allows cars to stop. Disadvantages of friction include wear and tear, energy loss, and heat production. Friction wears out surfaces. Friction wastes energy. Friction produces unwanted heat. To reduce friction, we use lubricants. lubricants reduce friction between surfaces. Examples include oil and grease. To increase friction, we use rough surfaces. Examples include sandpaper and tires. Understanding friction is essential for engineering and everyday life. Now let me explain tension. Tension is a contact force. It is transmitted through a string, rope, or cable. It acts along the length of the string. It pulls on the objects at both ends. Tension is equal throughout the string. This is true if the string is massless and frictionless. Tension is important in many applications. Examples include lifting objects, pulling carts, and suspension bridges. Tension is a common force in physics problems. Now, let me explain normal reaction. Normal reaction is a contact force. It acts perpendicular to a surface. It is the force that supports an object. It prevents objects from falling through surfaces. Normal reaction equals the weight of an object. This is true on a horizontal surface. On an inclined plane, normal reaction is less. It is equal to the component of weight perpendicular to the plane. Normal reaction is essential for understanding equilibrium. Now, let me explain applied force. Applied force is a force applied to an object. It can be a push or a pull. Applied force can change the motion of an object. It can start motion, stop motion, or change direction. Applied force is used in many everyday activities. Examples include pushing a cart, pulling a door, and kicking a ball. Applied force is a common force in physics problems. Now let me explain net force. Net force is the resultant of all forces acting on an object. It is the vector sum of all forces. If the net force is zero, the object is in equilibrium. It will not accelerate. If the net force is not zero, the object will accelerate. The direction of acceleration is the direction of the net force. Net force is essential for understanding Newton's laws of motion. Now let me explain Newton's laws of motion. Newton's laws are fundamental to mechanics. The first law is the law of inertia. It states that an object at rest stays at rest. An object in motion stays in motion. This is true unless acted upon by a force. The second law is the law of acceleration. It states that force equals mass times acceleration. The formula is F equals ma. The third law is the law of action and reaction. It states that for every action, there is an equal and opposite reaction. These laws are essential for understanding forces and motion. Now, let me explain Newton's first law in detail. Newton's first law is the law of inertia. Inertia is the tendency of an object to resist changes in motion. An object at rest tends to stay at rest. An object in motion tends to stay in motion. This is why objects do not start moving on their own. This is why moving objects do not stop on their own. Friction is a force that opposes motion. Without friction, objects would move forever. Newton's first law explains why seat belts are important. In a sudden stop, your body tends to keep moving. The seatbelt provides a force to stop you. Now let me explain Newton's second law in detail. Newton's second law is the law of acceleration. It states that force equals mass times acceleration. The formula is F equals ma. Acceleration is directly proportional to force. This means more force means more acceleration. Acceleration is inversely proportional to mass. This means more mass means less acceleration. Newton's second law explains why heavier objects are harder to push. It explains why lighter objects are easier to push. Newton's second law is essential for solving many physics problems. Now let me explain Newton's third law in detail. Newton's third law is the law of action and reaction. It states that for every action, there is an equal and opposite reaction. When you push on a wall, the wall pushes back. When you jump, you push down on the ground. The ground pushes up on you. Action and reaction forces act on different objects. They do not cancel each other. Newton's third law explains many phenomena. It explains why rockets work. Rockets push exhaust gases backward. The gases push the rocket forward. Understanding Newton's third law is essential for understanding interactions. Now, let me explain the principle of moments. The principle of moments is used for objects in equilibrium. It states that the sum of clockwise moments equals the sum of anti-clockwise moments. A moment is the turning effect of a force. It is calculated as force times distance from the pivot. The unit of moment is the Newton meter. The principle of moments is used to solve problems involving levers and beams. It is essential for understanding equilibrium. Now, let me explain the conditions for equilibrium. Equilibrium occurs when an object is at rest or moving at constant velocity. There are two conditions for equilibrium. The first condition is that the sum of all forces is zero. The net force is zero. The second condition is that the sum of all moments is zero. The net moment is zero. These conditions apply to static equilibrium. Static equilibrium is when the object is at rest. These conditions are essential for solving problems involving equilibrium. Now let me explain the applications of forces. Forces have many applications. Forces are used in transportation. Engines provide forces to move vehicles. Forces are used in construction. Beams and columns provide forces to support structures. Forces are used in sports. Athletes apply forces to balls and equipment. Forces are used in medicine. Forces are used in physical therapy and rehabilitation. Understanding forces is essential for many fields. It is essential for engineering, architecture, and sports science. Now let me give you sample exam questions. Define force. A force is a push or pull on an object. State Newton's laws of motion. The first law is the law of inertia. The second law is F equals ma. The third law is action and reaction. Explain the difference between mass and weight. Mass is the amount of matter. Weight is the force of gravity. Define friction. Friction is a force that opposes motion between two surfaces. State the principle of moments. The sum of clockwise moments equals the sum of anti-clockwise moments. Let me summarize. A force is a push or pull on an object. The types of forces include gravitational force, friction, tension, normal reaction, and applied force. Newton's laws of motion describe the relationship between forces and motion. The first law is the law of inertia. The second law is F equals ma. The third law is action and reaction. Friction opposes motion. The principle of moments is used for equilibrium. Understanding forces is essential for physics. Practice these concepts. When you have them down, move to topic 5.